response from the server says, okay, I accept your request to upgrade the connection. We're going to now switch protocols and upgrade to the WebSocket type of connection. So when that happens, when a WebSocket connection is established, and depending upon the browser you're using, you'll be able to see, you'll be able to see the frames, the messages that are being sent back and forth from client to server or server to client. And what's intriguing about this, or one of the big deals about it, is that you're sending significantly less data across the wire. So normally, you'd be sending around 800 bytes of data per request and per response, headers and content included. At a minimum, that would be a normal sized request and response. Well, now you're just sending a beginning bit and an ending bit that says when the data starts and ends, and then in between those two, you're declaring what the actual data is. So you could be sending a very small amount of data. You could send 1 byte as a response, so a Boolean, if you will. And so this is an example and a screenshot of what the data being sent across the wire looks like. I believe this might be Chrome. So depending upon the browser you're using, some have better tooling than others as it relates to reviewing WebSocket messages. So how does a WebSocket connection work? Well, in the JavaScript world, it has some different concepts than what your typical RPG program would have, and a lot of it is based on things like events. So for example here, we're going to create a new WebSocket connection. This is the client-side code, and basically what we're doing is pointing it at the server that delivered this page, and we're saying, all right, let's make a connection to that domain and URL, so this would be my domain. And then we're setting up different messages to listen for. So when the connection is secured, we can be notified of that. So when the connection has been upgraded to a WebSocket connection, we're notified of that. Now, in this case, I'm just logging up to the console to say, hey, we've connected successfully. When I receive a message from the server, I'm also logging some out to the console, just declaring that I received this particular data. So this is what's called an inline anonymous function. And whenever a message is received, this function will be invoked, and I just pump out the data to the console. Now the console in this case is the browser's console. So you'll see it if you bring up what's usually called the developer tools within the browser. So I use primarily Chrome and Firefox. And then likewise and finally, when the connection is closed, I can be notified of that. And that's important if I need to make sure that I display something to the user if they lose connection. This is just more of a side note than anything, because it's a difference in strategy or what's normal in the web. So normally, when you're doing web applications, you're not supposed to or not allowed to even call out to other domains from your JavaScript in your browser. That's called cross-domain communication. Well, WebSockets allows that. So you can communicate from one to two different servers from the same browser session. And you can optionally restrict that. There's more information that you can read about that at the below Stack Overflow link. And you can learn about how to restrict domain access. But otherwise, just know that that is on by default. All right, so I just wanted to make note of a couple things. So these two tools are based on Node.js. The back one is a browser-based IDE, which we'll be using on Saturday. And that's written in Node.js and uses WebSockets here and there. And then the front one is a Git GUI interface. So if you noticed here, I've got it says /home/Bartel, and it's got a Git repository path. So that's a path in my IFS, and then I can more easily manage my source code visually using the Git tooling. So I can easily make commits and pull from I'm a remote Bitbucket server, so on and so forth. So very cool tooling that's available to us with Node.js and WebSockets. So I'd encourage you to check it out. So these are free and open source. All right, so let's look at our first WebSocket application. So this is using Node.js, like we discussed. And in particular, it's using a Node module called Socket.io. And this is one of the really cool aspects of Node.js that I like. And I'll just mention it briefly. One of the biggest advantages of Node.js is you have a single language syntax on both the client in the browser and on the server on IBMi. So Node.js is JavaScript. It's JavaScript on the server side. Socket.io is a single Node package, Node module, that facilitates both the client-side code for WebSockets and the server-side code for WebSockets, which makes it very, I'm drawing a blank on the word, but it's very well-rounded. It takes care of both ends of the spectrum, so it can simplify things a lot. So let's take a look at what the code looks like. All right, so this is the entirety of the server-side code. So this is in a file called app.js. And basically what I'm doing up at the top here is I'm bringing in outside capabilities. So I don't know how much you guys know about Node.js yet, so I am going to digress through some of this code and describe what it's doing. So these require statements are very similar to /copy statements in RPG. I'm bringing in outside functionality, similar to how I'd make use of an RPG service program from another RPG program, like a /copy statement. So when the app is first loaded, a user will make a request to the web server, and then it will deliver down the index.html file. So let me just go and look at the index.html file. It's on the next slide here. All right, so this is the index.html file, and basically what we have here is the HTML necessary to display that chat screen that we saw on the first page. So we've got an unordered list. This will be the place where the messages, the chat messages, are displayed. We've got our form. It's got an input field called M and a send button. And then here we're bringing down the Socket.io JavaScript. So this is actually coming down from what's called the CDN, a content delivery network. That's just basically an extremely high-speed web server that's got a nice pipe to the internet that's serving up static content. And it also can, if somebody's loading up your website from a different country, it can sideload that. So instead of pulling it from a server in the United States, it can pull it from a server in that other country. So that's what some content delivery networks do. Also, we're bringing down jQuery. And jQuery really helps me work with the UI components that are within an HTML page. So let's jump right into that. So here's really where the meat and potatoes happens. So within this script tag, I define all of my client-side code. So here, I'm initializing the socket connection, a WebSocket connection with my IBMi. So underneath the covers, it's doing that handshake, that upgrade of the WebSocket connection, and storing it in a variable. Then, with jQuery, I set up some listeners and selectors. So I'm basically saying with this selector, look for a form tag on this page, which is right here. And when that form is submitted, invoke this inline function. So the interesting thing about JavaScript is this is code that's actually being passed as a parameter to this method, to this submit method. It's being passed as a parameter to be invoked at a future point in time. Now, when it is submitted, when the user presses that send button, what happens? Well, it's going to make use of the client object and call on its emit function. It's going to emit a message up to the server. And I like to correlate this to being similar to doing a key data queue write. So a key data queue has a key area and a data portion of the record. Well, the key in this case is the key is chat message, and the data portion contains the value that existed within the input field. So here again, we're using a jQuery selector to obtain the value of that input field, and then we send that up to the server. So we emit that message, and before we're done, we also clear out that input field, and then we go into a wait state and wait for subsequent messages. So let me go back a slide, and we'll go back to the server-side code. So now, when a connection is made, so I'm listening, this is an event listener, so it's listening for an on-connection event. When a connection is made, meaning a client makes a request to the server and upgrades to a WebSocket connection, then this code from here down to here is invoked. And this code does two things. It sets up a listener for when the user disconnects. In this case, all we're doing is spitting out something to the log. And then it's also going to listen for, and this is the key, the chat message. So if a client, a browser, emits a message that has a key of chat message, then it will invoke this inline anonymous function. So here's the start of the function, and here's the end of the function. And what the server now does is it will emit that message to all of the other browsers that are also on this same page, that are also listening for chat messages to be sent from the server down to the client. Now remember, these clients are not polling the server for new information. They're waiting for the server to send down new information. And that's what's happening right here. So this is the server sending down information to the client. All right, so now let's go forward a slide and look at the rest of this code. So this is the client waiting for an event called chat message, waiting for that event from the server. When it gets that event, it invokes this inline anonymous function. What does it do? It uses a jQuery selector to gain access to the messages unordered list. It then appends a new list item tag and sets the content of that tag to whatever message was sent back from the server. So that completes the whole life cycle of this particular application. So if anybody's got their laptop open, we can go ahead and give this a quick try. So this is me in my browser-based environment. And let me just open up the application and make the font a little bit bigger. So this is the application, and I omitted the style sheets on the previous slide. But let's go ahead and start this up. And here I'm inside of Pace. So I'm inside of a shell session in Pace. So Pace is the Linuxy side of IBMi. It's actually AIX that uses IBMi as its kernel. So now I'm within this WebSock directory. And if I list the contents of this, I can see that I've got a number of files. So I want to go ahead and start up the WebSocket application. So I'm going to type in node. So node is my runtime. And then node needs to know what file it needs to run. So it's going to run the index.js file. On my slides, I think I actually called it app.js. So there's a slight change in there. And if you look at the code, we can see that we're listening on port 60263. So if I go over here and refresh this, so I'm on spaces.litmus.com, port 60263. So if anybody else wants to load up that same page, feel free. So this is the chat app. And we can see how it's doing the initial request to the server. It downloads the JavaScript, so this is socket.io, jQuery, and then it starts asking the server different questions. And in particular, this last one down here, or the second to the last one, oh, there we go, we got participation. Hi, Roman. And we've got the client upgrading to the WebSocket connection. So here's the 101, HTTP responsive 101. So it's switching protocols. Now, so that's the entirety of the chat application. And again, it's using WebSockets under the covers. And it's pretty cool stuff. Obviously very simple. It might not be something, you might not need a chat app for your business application. But just think of potentially how you could use some of these things. So for example, imagine that if you had real-time screen updates, you could have two different people in the same customer master record editing a customer, and they both see each other's changes on the screen in real time. So it just changes how we should be looking at applications in the future and saving information and not only interacting within our company but also interacting with customers. So some very cool stuff. All right, let's get back to the presentation. Let's talk about Watson. So if anybody's been living under a rock and you need to know what Watson is, it's basically cognitive computing. And it started back with the big announcement that Watson was going to be competing in Jeopardy against some of the best in the world. And Watson won. And there's a number of things that have happened since then. So IBM didn't just create a computer that could play games. It's brought it much further. It's, I'm not sure if they actually coined the term, but they're entering what's called the cognitive computing space, where, in short, cool things are happening. There's a variety of different things that I've got up here on the screen of APIs that they offer. So for example, visual recognition, they can look at a picture and describe what's actually happening in the picture. So it can recognize whether there's humans in the picture, and it can do facial recognition to say, well, this particular picture looks like it's got Imam in it, and this one looks like it's got Aaron in it, and stuff like that. So cool stuff happening there. The one we're going to be looking at today is the speech-to-text, and that's just because that's the first one I tried, and it was very easy to get up and running, actually. All right, so let's dive into that. I actually wrote an article on how to do this, so if you go to this URL, and I can get you this slide deck after the session here, so don't worry about that. It describes the steps I took to get up and running with this particular Watson application. Now, the cool thing about this, and the kicker, is that you can gain access to Watson for free. So I have a developer account, and I have an allotment of requests I can make up to Watson in the cloud per month before I would ever get charged for anything. So this is a really cool way that you can start adopting Watson capabilities into your shop without having to ask permission to get out the checkbook and start paying for things before you know it's actually going to be an advantage for you. So go ahead and check that article out so you can see how I accomplished it, though I'm also going to be going through it in the coming slides here. All right, so getting into some geek stuff here. This $ means I'm again at a shell prompt, pace. I'm in the IFS. I'm on IBMi. And for the sake of letting you know where I'm at in my directory structure, I do the pwd command, print working directory. So this is where I'm currently sitting in the IFS. And then I'm going to run what's called a git clone command. So git is source change management tool, extremely popular. The majority of the open source world uses it. Just actually got released with license program 5733 OPS on April 12th, so that's only a few days ago. So IBM is now including it in that license program, so it's free for you to use. So please go ahead and download it, and there's a bunch of tutorials out on the web that you can follow that are IBMi specific. So we're doing a git clone. What that basically does is it goes out to github.com, downloads the source code, and puts it on your IBMi. And so now at this point, you're ready to get up and running with this Watson API set. So I'm going to, after I do a git clone, it created this directory in my IFS. I'm going to cd into that, change directory into speech-to-text Node.js. And then I'm going to run this npm install command. So what this is going to do is it's going to look at what's called the package.json file, and that file declares what dependencies this particular Node.js application has. So what other Node modules does it depend on? It will go and download all those Node modules from npmjs.com and install them locally on your IBMi. So this is a very slick process and really speeds up development because we're operating and benefiting from open source. A lot of work that other people have done for us. So after we get done doing the install, next we're going to do the npm run build. Now you don't have to do this for every type of project you get from GitHub, just some projects. So I read the README file that was on the web for this project, and this is the part of the installation instructions. Well, what does it do? Well, underneath the covers, it's going to take and compile all the JavaScript. What does that mean? I thought JavaScript was a scripting language that didn't need to be compiled. Well, in this case, it's going to combine multiple files together and minify them. By minify, it takes out a lot of the white space, so extra spaces for indentation and tab characters and the like. But then on the combining front, what this will do is it'll actually take, let's say you had 20 JavaScript files that were going to be delivered down to the client. It'll put those all into a single file. And this is significant because normally when you deliver an HTML page down to the browser, it might have 5, 6, 7, 8, 20 references to JavaScript and CSS files that are back on the server. And each one of those needs to be a separate request to the web server to request that particular file to be downloaded back to the client. Well, by minifying them and combining them, all of a sudden we're making one request for our JavaScript and one request for our CSS because they've been included in two separate files instead of 20 or more. So definitely speeds up the round trip of an application loading in the browser. All right, so now that we've installed it, right now we just have source code, and we need to go ahead now and configure that source code. So how do we do that? Well, the way that the Watson APIs work is they kind of steer you towards and assume that you're going to run your Node.js code on their Bluemix platform. So it's a cool platform and all where you can run a variety of languages. But I really want to run this on my IBMi. So to do that, I do a little digging, and I've laid out the steps for you here. But at the end of the day, what we want is the username and password of our account so that we can authenticate from our IBMi to Watson. So they require you to authenticate so that if you do go over your monthly allotment, they can bill you accordingly. But like I said, I've never been billed yet, and I've been using it for a while here. So after you log in, you can get an IBM Bluemix account for free, by the way. You're going to create a space, so I called it space 1, and once the space is created, you click on it. And then you add a service, so you click on this Services and API button. And then you select the speech-to-text service. And once that's added, on the summary page, you'll click the Show Credentials button. And within there, you'll have the username and password. So what you'll do is you'll copy those. And I just realized I didn't put the name of the file here, so let me just escape out of here for a second. You're going to copy those two username and passwords, into the app.js file. So here I've copied them right into here. Please don't take note of those because those are my username and password. Oh, they're the things you do. And now that those are in there, my app is configured to do the request to Watson. All right, so let's go to the next slide. So the next step, after I've installed and ran the build of this speech-to-text Watson app, is to go ahead and start the application, and that's what I'm doing here. So I'm back in Pace. Here's the print working directory command again, and you can see that I'm inside that project. And then here I'm invoking the Node program. Now in the previous application we looked at, the WebSocket chat app, I didn't have this beginning portion. I just did node space index.js. So what's this? Well, this is what's called an environment variable, and environment variables are used to store values that an application like this might look to gain access to configuration information. So in the RPG world, sometimes what we do for that is a data area. Well, this is similar in nature. So what I'm basically doing here is I'm saying, Mr. App, when you start up, start listening on port 8001. So once that's started up, then we can go ahead and redirect our browser to that particular port. And so it's always good to have proof that all this stuff works. So I'm going to just go ahead and navigate to that particular application. Get a bigger font here. And I believe I may have hard-coded the port, so I won't specify here. So let's go ahead and try and start this puppy up. Oh, I've already got it started. Let's see. 1 second. Need to do some surgery. On the fly debugging. Let's see if I'm capable. I'm just going to upgrade the port there. Oh, duh, because I'm listening on it over here. All right, so I just ended that WebSocket application for the chat by hitting Control-C. So now I can go back over here. Actually, let me undo that. Control-Z, Control-S. Let's try to start this again. So notice I got this address and use error, so it couldn't attach to the port. All right, so now it's listening at port 60263. So if I go back over to here, let me just load up this tab. And let me scroll down. And it's asking if it can have control of my mic. And I'm going to say, yes, you can have control. So now you'll see text on the screen. It's basically recording everything I say. What's happening is that we've got WebSockets communicating with Watson. So basically, as I'm talking, my laptop mic is picking it up. It's making a WebSocket request to Watson in the cloud. Watson takes that audio and converts it to text, sends it back down to the browser, and then spits it out on the screen. So it not only does that, but if we scroll down, I also get a whole bunch of metadata. So it tells me how sure it was of each and every piece of data. So it's got the word that I said, how long that word took, so start and end time, and the confidence level. So a 1 means it's very confident, and then the 100%, and then the rest are partial confidences. So if I scroll down to the bottom, you can see that it's continuously updating. And it doesn't get everything right on the money. And it also does alternate hypotheses. That's pretty cool too. And this is all being updated also in real time. Okay, so this is nifty and whatnot, but what's the practical application? So imagine a world where you might have some customer service reps and you want to gain additional insight, analytics on how your customers perceive you. So you can have those conversations be recorded, have them be converted to text, and then do queries of some sort, SQL or other, that look for particular phrasings like I'm frustrated, or I want a refund, or what have you, or you made my day, whatever the situation might be. So there's a lot of different ways that could be used. All right, let's go back into the presentation. So we looked at this. Again, there's statistics that are being returned back. Alternate hypotheses. So it's a pretty cool feature. Just it's different guesses of Watson. So again, this is cognitive computing. It didn't just stop at what it thought the first thing was of the transcribing, but it went even further. All right, so that was Watson. And the last thing that we're going to be looking at is something that, an open source project I started. It's called IBMi, short for dashboard. And it's basically an app that I started creating because I wanted to test all of the DB2 services for I. So if you go to this bit.ly link, you'll see that IBM has been providing all these different, basically SQL statements that give me dead simple access to a variety of features. So for example, I can run an SQL statement that gives me a listing of all of the active jobs on the system. So that's what this particular WebSocket application is going to look at. So this is just a partial of the index.js file. This is the server-side code. So basically, when a browser makes a request to /workActiveJob, what it's going to do is it's going to render the WorkActiveJob page. So let's look at that next. And this is what's called JADE syntax. So it looks kind of like HTML, except for it's more concise and maybe even terse. But basically, it doesn't have the less than and greater than signs, and it uses indentation to know when tags should be closed. So in short here, though, let's look down at this area of code. So this looks familiar, going back to the chat application we looked at earlier. Here, we're initializing the WebSocket connection, and then we're creating a listener. So when a WorkActiveJob_update event is emitted, here's the steps we're going to take. We're going to invoke this inline anonymous function. So we're going to iterate over the data that's passed back to us. So a lot of this code is just busy work code. But at the end of the day, we're going to add all of the new WorkActiveJob data to a particular object on this page. So in this case, we're going to look at the HTML entity that has an ID of jobs. So that's this right here. And you can see we're altering the table body with the new information that was downloaded from the website. So going back to the previous slide, how does that information get down there? Well, what we're doing here is we're setting an interval so that every 2,000 milliseconds or every 2 seconds, we're going to run this select statement. So the selection is of these columns, but most specifically, this qsys2.activeJobInfo is one of those DB2 for I services. This is one of the things that IBM provided in, I believe, it was a technology refresh. And basically, this is going to run every 2 seconds. So this is a connection to my IBMi database connection from Node.js. And then it's going to emit an event of work active job underscore update down to every client that's listening for events. So if I go forward again to the HTML, I'm listening for that event in the client side. And so if I go back 2 slides, this is what the screen looks like, and every 2 seconds this screen will receive an update from the server, and it will contain the job, the user, the disk I/O, and the CPU. So this is a nice little way that we can see yet another example of how WebSockets could be used on IBMi. Oh, so that is WebSockets, Watson, Node.js, all on IBMi. Does anybody have any questions?
Thanks, Aaron. I'm just going to, does anyone have any questions for Aaron? Please raise your hand if you do.
Someone may have already asked this, but will he be able to send us the PDF of the presentation?
Yeah,
Yep.
I've recorded most of it. I didn't start until 10 minutes into it, so I'll give that. But yeah, Aaron, if you could provide the PDF.
Absolutely.
Okay, I'll invite anyone. There's actually about 18 people on the web, dialing from everywhere. If any of you on the GoToMeeting would like to ask a question, go ahead and unmute and ask away.
I got a comment from Roman. What's the agenda for Saturday's workshop? So if you go to oceanusergroup.com, you'll be able to see the agenda. So basically what we're going to be doing is going through some introductory sessions of Node.js for the morning portion, describing what the language is, how it works, doing some CRUD-based applications. And then in the afternoon, we'll be going through a full lab where you'll be able to set yourself up on the same environment that I was using here. So it's basically a browser-based development environment that's on an IBMi in the cloud. And you're going to walk through the creation of a Node.js application from start to finish. Any other questions? All right, Alex says, are there any Node.js examples out there of DB2 access that fetch one record at a time instead of requesting a full record set at once? For files that have millions of records, this is more practical. I'm trying to think if there is a specific example of that. There might be one. I might have one in an article. Actually, in the lab, I know there will be one. So basically, well, it goes after one record based upon the key. It's still a result set, but you only go after the first row in the result set. So you'll see that in Saturday's lab. Any other questions? By the way, what I just brought up on my screen is the DeveloperWorks site for Node.js on IBMi. So this is a Node.js page to get dedicated to IBMi. And on here is the DB2 access APIs. So you can go in here and see all the different ways to access DB2 from Node.js. Oh, I got another one from Roman. How do you call Node.js script from RPG ILE? So that's a good question. That's actually a hot and new project that Tony Cairns started. So if you go to Bitbucket and go to iNext, so this is Tony Cairns. He's an IBMer that does a lot of open source related things. He's out of Rochester. And this VLang RPG project is something that just got started not too long ago. And essentially what it is it puts RPG in the controller seat. So RPG can invoke PHP, Node.js, Ruby, other scripting languages, Python, directly. So we're not communicating over data queues. It's actually loading up pace in the same job, making a call to PHP in this case, and then I wouldn't say the complication, but what might be new to you is it utilizes a callback infrastructure to make a call back into the RPG program. So check this out. You can see the URL at the top, bitbucket.org inext/vlang-rpg. And if you forget that, just let me know and I can email it to you. Roman says, cool beans. Any other questions?
Going once, going twice. Okay, I think we'll bring it to a close. So Aaron, thank you so much. Big round of applause. That was excellent.
My pleasure.
See you on Saturday.
Yeah, Margaret's saying we'll see you on Saturday.
Rock on. I'm looking forward to California.
Great, thank you, Aaron. Thank you, everyone, for joining up on the web, on the online GoToMeeting, and we look forward to seeing you in person soon.
And thank you so much.